Determining slope between 2 points. So those points would be x1, y1, and x2, y2. So in the last lesson, we reviewed how we find the slope of a graph from a graph. And we do that by drawing our triangle that would be made using between those points and looking at the rise over the run. So for this example to the left-hand side, our rise, well, first of all, our units go up by ones from our scale. So our rise is 1, 2, 3, 4, 5. So the slope is 5 over 1, 2, 3. So that's our slope there. And we can keep that as 5 over 3. So we can keep it as an improper fraction. That's perfectly fine. So remember, rise over run. Now there's going to be times when we're not going to have graph paper with us, or we don't want to have to sketch a graph. And so it's important that you understand how to find the slope of 2 points. So how do we find the slope of a line given the coordinates of 2 points? So let's take a look at the points on this graph. So we've identified how we can figure out the coordinates of a point earlier. So let's take a look at this first point here. So I'm going to call this point A, and the second one point B. So the first point has a coordinate of +1 and -1. So I'm going to write that down here. And the second point, point B, has a coordinate of +4 and +4. So now that I've identified what the coordinates are from that graph, we're going to use that information to find the slope. So I'm going to let my first point be x1, y1, and my second point be x2, y2. So I'm just identifying which is point 1 and which is point 2. If you wrote these at the opposite direction, and you labeled them 4 as x1, y1, and 1, -1 as y2, y1, or x2, y2, you would get the same slope regardless, okay? So don't be too alarmed if you mix the order up of your slopes, of your coordinates. So remember, the slope is the same as rise over run, which is the vertical change between 2 points over the horizontal change of 2 points. So when we're looking at using this with our slope formula, we want to look at something where we're looking at the difference between the vertical change. And we do that by taking our y2 and we're subtracting our y1. So we're looking at the y coordinates and we're finding the difference between those 2 points. And when we're looking at the horizontal change between the 2 points, we're going to look at our x coordinates, and we're going to look at x2, and we're going to take away x1. So if the slope is the same as rise over run, which we have up here, we can rewrite that as y2 minus y1 over x2 minus x1. You may also see this written as delta y over delta x, where delta is a Greek letter, and that just refers to as the difference. So you can see it, sometimes you'll see it written like this. Know that that's the same as this. So y2 minus y1 over x2 minus x1 is the same as delta y over delta x. So what is our y2 minus our y1? So our y2 is our 4. Our y1 is our -1. So we're subtracting -1. So don't forget to include both of those signs. And then for my run, so my x2 minus x1, my x2 is 4. And my x1, is +1. So 4 take away 1. So 4 take away negative 1 is the same as 4 plus 1, or 5. And 4 take away 3, or 4 take away 1 is 3. So you'll notice that using our slope formula gives us the same slope as if we were to figure out our slope graphically. Let's go through another example. So we have the points 3, 5, and 2, negative 1. So sometimes you might just show underneath your points that this is going to be x1, y1, and then for your second point, x2, y2. And again, if you switch these up, that's fine, okay? So that's step 1. Assign x1, y1 to one point and x2, y2 to the other point. So now we want to substitute the values into the slope equation. So we're going to use the slope is the same as y2 minus y1 over x2 minus x1. So that is going to be the same as 1 take away 5 over negative 2 take away 3. So I'm going to simplify that. 1 take away 5 is negative 4. And negative 2 take away 3 is negative 5. If the numbers on the numerator and the denominator are both negatives, then you can simplify this as 4 over 5. If one is negative and one is positive, then it would stay negative. But if they're both negative, then you can write it as positive. So this tells us we have a positive slope of 4 over 5. So let's just verify that by plotting those points. So you don't always need to verify it, but if you have a graph available to you, it's helpful to do that. So I'm going to plot my points 3, 5. So I'm going to go across to 3 and up to 5. So this is point 1. And my point 2, I said, was negative 2 and 1. So I'm going to go across to negative 2 and up to positive 1. So this is point 2. So you'll notice that actually when I chose the values for my point 1 and point 2, it's different than if I was to read this from left to right. And that's okay. Okay? So now I want to connect these points. And I want to show, sometimes we call this the rate triangle. I want to show the triangle that's made by connecting those 2 points. So my rise and my run. So my rise is 1, 2, 3, 4. My run is 1, 2, 3, 4, 5. So my slope from this graph is 4 over 5, which is exactly what I got when I did this algebraically.